Hello everyone. Welcome to the course of lecture Testing and Commissioning of Electrical Equipment. Here we are on lecture number 41, Cooling and Enclosure of Synchronous Machines. Not only for synchronous machine, it is common to all rotating electrical machines. First of all, we should know what is cooling system and what is the need of cooling system for electrical machines and its principle. So it is a process by means of which heat resulting from losses occurring in a machine is given up first to a primary coolant by increasing its temperature. A heated primary coolant may be replaced by a new coolant at a lower temperature or may be cooled by a secondary coolant in the form of heat exchanger. Then what are the need for standards for degree of protection and cooling system for electrical equipment? So it totally deals with types, designation, recommendations regarding ratings, types, testings, etc. The standardization helps in reduction of variety and is useful to manufacturers, that is users and consultants. Every electrical equipment needs protection of internal parts against atmospheric dust, moisture, water, corrosive gases, etc. Secondly, the casing of the electrical equipment should be such that there shall be no possibility of accidental contact of human beings with the live parts of electrical equipment. So these aspects are covered on the standards for degree of protection. That is, the purpose of standards on degree of protection and cooling system is to ensure good understanding between the manufacturers and users of electrical equipment with respect to related aspects. The heat due to losses in the machine is imparted first to primary coolant by raising its temperature. The heated primary coolant may be replaced by a new coolant at a lower temperature or may be cooled by secondary coolant in some form of heat exchanger. Then, the I squared R losses and other losses in electrical machine appear as heat rising the temperature of each internal part above the ambient temperature of the surrounding air. The temperature rise is related to the rate of heat production, the rate of cooling, and the thermal capacity. The temperature rise is significant as it affects the life of the winding insulation. Heat is removed by a combination of conduction, convection, and by radiation from outer surfaces. The heat exchanger, it is a component of cooling system that transfers heat from one coolant to another by keeping the two coolants separate. Then what is inner cooled winding? That is direct cooled. A winding which has either hollow conductors or tube which form an integral part of the winding through which the coolant flows. So the terms and definitions about the coolant system is very important. So we have primary coolant, secondary cooling, heat exchanger, and inner direct cooled winding. After that, we will see open circuit cooling, closed circuit cooling, standby or emergency cooling type, dependent circulating circuit component, independent circulating circuit component, integral circulating circuit component, machine mounted circulating, separately mounted circulating circuit component. So first, what is indirect air cooling? Air cooling in closed circuit used for units up to 50 megawatt. Clean, dry, cool air is blown along the air gap between the stator and rotor through ducts in the core and over the surface of windings. Heat transfers from windings through insulation to the rotor and stator teeth, then to cooling air. Hence, it is called indirect cooling. That is, air circulates through a closed cycle through the generator and heat exchanger. Fan provided at each end of the rotor to ensure flow of air through generator. Then indirect hydrogen cooling is also there. For generator units larger than 50 megawatt, hydrogen cooling system is used. In indirect hydrogen cooling, the hydrogen gas is circulated through the machine by means of fans provided internally at each end of the rotor. The hydrogen gas is circulated through air gap. Here, from winding, heat is passed through insulation and teeth to the gas. Gas is circulated through heat exchanger is closed cycle. It is meant as closed cycle. Hydrogen has density about 0.076 times that of air and specific heat 14 times of air. So it needs gas control equipment, shaft seal arrangement. A wide range of audio and visible alarms are fitted for detecting and indicating leakage of oil or gas. Then we will see direct hydrogen cooling. The hydrogen gas is passed through conductors or through ducts near the conductors for very effective cooling. Hence, higher current density can be used for same permissible temperature rise. So here, open circuit cooling and closed circuit cooling. A method of cooling in which the coolant is drawn from the medium surrounding the machine, passes through the machine, and then returns to the surrounding medium. It is totally of open type. Then closed circuit. The primary coolant is circulated in a closed circuit through the machine and if necessary through heat exchangers. Heat is transferred from to the secondary coolant system. Further, the cooling system may be standby or emergency cooling system, dependent circulating circuit component, independent circulating circuit component, integral circulating circuit component, machine mounted circulating circuit component, separately mounted circulating components. So the nature of the coolant are designated by one of the following letters, right? Gases like air, hydrogen, nitrogen, and carbon dioxide. This is denoted as A, H, N, C respectively. And liquids such as water and oil denoted as W and U respectively. For all other coolants, the nature of the gas or liquid should be stated in full description. When all the coolants are air, it is permissible to omit the letters stating the nature of the coolants. Here, hydrogen cooling of turbo generator. So, what are the characteristics of hydrogen? So, thermal conductivity of hydrogen is about 7 times that of air. The density of hydrogen is also 0.07 times of that air. Specific heat of hydrogen is 14 times of the air. Hence, hydrogen gas is preferred to air as a coolant in large turbo generators of capacity 60 megawatt and above. It reduces noise and improves heat transfer. Hydrogen cooling is direct cooling. The cooling medium is in direct contact with contactors. So the thermal conductivity of hydrogen is very much important for this cooling system. The hydrogen gas is passed through the rectangular tubular cross-section rotor conductors. The stator conductors are hollow and hydrogen gas from a separate circuit is circulated through stator conductors. The pressure of the gas is about 1.5 kg per meter squared and flow rate is also high. Hydrogen blowers are required to circulate the hydrogen gas through direct cooled machine. So the water at higher speed efficiently removes the heat. So these are all the ABB industry having the synchronous motor, having the type of coolant system they are using in the machine. An open air-cooled motor with drip-proof protection. First picture shows that drip-proof protection. And totally enclosed type is others. Here, it is using air to water or water to air. This type here, you are seeing air to air closed circuit cooling. The cooling air circulates in the closed circuit through the active part of the motor through air-to-air heat exchanger. This solution is especially used where water is not readily available. This cooling arrangement requires an additional shaft-mounted or separate electric fan to ensure sufficient airflow through the cooler. So these are all the standard designations of synchronous machine coolant system. Suppose it may be noted as IC11, IC30, and some of the characteristics in the standard designation of the cooling system also to be involved. That is, for example, we have free circulation of coolant material, inlet pipe or inlet duct circulated, outlet pipe, inlet and outlet pipe, frame surface cooled, integral heat exchanger, surrounding, machine mounted heat exchanger, and separately mounted heat exchanger. Many types are there for different machines, rotating machines. So it may be of radiation, convection, and conduction. The movement of coolant is by temperature differences. The fanning action of the rotor is negligible. That is in the case of convection. Okay, it is free, totally free. Self-circulation. In the case of self-circulation, the movement of coolant is either by a fanning action of the rotor alone by means of component designated for this purpose and mounted directly on the shaft of the machine. The circulation by integral dependent component is by means of an integral component not mounted directly on the shaft of the machine. Then circulation by dependent component mounted on the machine is by movement of coolant is an electrical or mechanical intermediate component mounted on the machine like a fan driven electric motor, and circulation by integral independent component. Many other things are there. So with the name implies it's cooling system movement. And here we have the standard designation as IC01, IC03, IC0041, IC0141, IC0151, and ICW37A71. So these are all the standards. So that describes whether it is inlet pipe or outlet pipe, or what are the type of circulation, self-cooled or fan-cooled, plain ribbed frame, totally enclosed type, or hydrogen cooled machine, like that it may denote. Then after that cooling system, we should know about some of the enclosures for rotating machine. So here various types of enclosures for rotating electrical machine and the type of cooling adopted in them is described here. The method of cooling is closely related to the construction and type of enclosure of the machine. So here first we are seeing about open pedestal type. In this, stator and rotor ends are open to the outside ambient air, the rotor being supported on pedestal bearings mounted on the bed plate. Open end bracket. Next type. In this, the bearing forms part of end shields which are fixed to the stator housing, the air in the comparatively free contact with the stator and rotor through the opening. This type is common for small and medium-sized motors and generators. This is the open end bracket type enclosures, right? Then after that, we will see protected or end cover type with guarded openings. The protection may be by screen or by fine mesh covers, right? So this is totally protected. End cover is there with guarded openings. Some openings are there, through that air may circulate. Then drip, splash or hose proof. Here, a protected machine with the openings in the end shield for cooling. The end shields are designed to prevent entry of falling of water, dirt or jets of liquid. Then after that, pipe or duct cooled, with end covers closed except for flanged openings for connection to cooling pipes. Here see, you are seeing this is totally enclosed type. The pipes are provided to that air is circulated inside that motor parts, okay, without affecting its insulation level. So it may be air to air or air to water, like that. Many are there. Already we have discussed about the coolant system. After that, we will see totally enclosed type, in which enclosed air has no contact with the ambient air. The machine is almost airtight. Total enclosure may be associated with an internal rotor fan, an external fan, water cooling or closed air circuit cooling. Here, air is circulated to a cooler and returned to the machine. See, you are seeing the fan. With the support of this fan, we have the air circulation through the machine. Then we have the weatherproof watertight. It may be called watertight also. Okay, weatherproof type. So here you are seeing, see, main terminal box, water inlet, and here you have many coolant circulation arrangement hoses. It is like a hoses. Then water outlet is here. Then it is on the terminal box. Then one more, flame proof or explosion proof, for the use in hazardous locations such as mines, chemical factories, stores, etc. It may be noted that the rating of machines are dependent on their respective cooling system. For complex cooling system, the machine have to be derated. So normally we have the airflow of different types. That is radial flow, axial flow, combined radial axial cooling, multiple inlet cooling. So these are all under the category of the types of flow in the air circulation. So the path of air circulation for totally enclosed machine, it is somewhat one more topic. That is here how the machine have no air contact with the outside. That is also explained here. What are the scope of standard recommendations for degree of protection? That is one of the important question for this coolant as well as our enclosure system. It is like a protection, right? So standard degrees of protection by enclosures applicable to electrical rotating machines as regards the protection of persons against contact with live or moving parts inside the enclosure and protection of machines against ingress of solid foreign bodies. Protection of machine against harmful ingress of liquids. Designations for these protective degrees. So for this, tests to be performed to check that machines meet the requirements of the standard recommendations. So these are all about our protection, enclosure and coolant system. Okay. The cooling system, what are the types of cooling system, and the types of flow also we have seen. And this is type of ABB synchronous motor, and type of enclosures we have seen. Types of enclosures and standards for the protection, enclosure and cooling system we have seen. So this lecture will give you the detail about the enclosure, cooling system and the standards ratings necessary for the rotating machines. That's all about this lecture 41. So hope you understand these concepts. Thank you all. Next we will see in other lecture that is totally deals with testing of synchronous machines. Thank you.